Okay, we're going to continue our unit on rational numbers, and one thing that we've kind of already talked about a little bit, but we're going to revisit, is converting between fractions and decimals using equivalent fractions. So we're going to be flipping back and forth between your math journal and the exercise packet that you received in class. And so I will tell you when you're going to be doing that. So for this first example, you're going to write this or copy it into your math journal. So this work until I tell you to switch will be in your math journal. All right, so you want to answer the question, what are some examples from real world where decimals are used? Go ahead and jot down a couple. Make sure you leave some room so that you can add. When I reveal the answer, you can either edit your answer or add to it. So maybe some things you wrote down are money or the metric system or any other examples that you came up with. The second question, what are some examples from the real world where fractions are used? So go ahead, stop the video and write down some examples of where you see fractions, and then continue the video. All right, so you might have written down maybe in carpentry or at maybe a home improvement store like Home Depot or Lowe's, cooking, and there's a bunch of other places where you see fractions used in the real world. Have you ever seen a recipe call for 2 7/10 cups of flour? Why or why not? Why do you think we don't see decimals when it has to do with recipes? Well, because measuring cups that you buy at the store are usually labeled with halves or thirds or fourths. And recipes requiring measurements are usually in fractional cups, so that's why you usually don't see anything in decimal form. How do you think people would react if a local gas station posted the price of a gallon as 3 3/7 per gallon? And why do you think they would react that way? Well, dollars are never measured in halves or thirds of a dollar. We always measure dollars in decimal form using tenths and hundredths. So it'd be $5.37, which is 0.37 or 37 hundredths. So that's why if someone were to post it as 3 3/7 per gallon, you'd probably have a lot of people asking, what is 3/7? All right, so now we're going to do example 1 on your worksheet packet. So keep your math journal out, but this next series of questions will be done on the worksheet. First of all, it should ask you to describe why we need to know how to represent rational numbers in different ways. So why do we need to be able to represent them as fractions, and why do we need to represent them as decimals? Well, because different situations in the real world require different representations of rational numbers, and then you need to add your own examples. So give an example of a fraction representation in the real world, and give an example of a decimal representation. All right, example 2 on your worksheet, using place values to write terminating decimals or equivalent fractions. So what is the value of the number 2 25 hundredths? How can this number be written as a fraction or a mixed number? Well, you can write it out in words, 2 25 hundredths, or you can write it as a fraction, which would be 2 25 over 100. I know we've already had a big long discussion as to why decimals were created, and again, it's just another way to represent fractions. All right, so to think about, when I ask you to think about, you don't necessarily have to write this down unless you think this would help you on a test later on. But how do we rewrite this fraction or any other fraction in its simplest form? So we had the fraction 2 and 25/100ths. We usually want to write that in a simpler form. How do we go about doing that? Well, first you want to find a common factor that is related to both the numerator and denominator of a fraction. I had you guys prime factor the numerator and the denominator so that you can show all the factors, and then we used the cancellation law to cancel out what was common between those two factors, or those two numerators and denominators. So a fraction can be simplified, resulting in a numerator and denominator of only having a common factor of 1, and the numerator and denominator are relatively prime. And the reason why they say relatively is 4/5. Well, 4 is not a prime number, 5 is, but there are no other common factors between 4 and 5. All right, so going back to your worksheet, let's answer part B, 1B. Write the fraction in its simplest form, showing all the steps that you use. So again, going back to 2 and 25/100ths, show your work as to how to simplify this. Now again, the work they show here is a little bit more condensed from what I've shown you, in which we would prime factor 25 into 5 times 5, and prime factor 100 into 2 times 2 times 5 times 5. But again, once you get proficient in this, you can simplify it even more and keep the 25 and split up 100 into 2 factors of 4 and 25, and therefore all you have to do is cancel out the 25 over 25. So what is the value of the number 2 and 25 thousandths? How can this number be written as a mixed number? Well, again, to spell it out, it would be 2 and 25 thousandths, or 2 and 25 over 1,000. And rewrite this fraction in its simplest form, showing all the steps that you used. Again, try to do this on your own before continuing the video and revealing the answer. All right, you should have it split up into, again, if you prime factored it more than what they have here, that's completely fine. But 1,000 is 100 times 10, which is also 4 times 25 times 10, and now you can cancel out the 25s and get 1/40th. If you're using your calculator on this, that's fine to check your work, but realistically you should be doing this manually. All right, so exercise 1. You're going to do this on your own. So complete exercise 1, letters A through D on the worksheet, and then continue the video to check your answers. All right, go ahead and pause the video again and check your answers. Make sure you have all the work shown, since this will be the work required to gain credit on your assessment. When you're done, go ahead and continue. All right, let's go back to your math journal again and do some Q&A note-taking. So what do you notice about the denominators of fractions that represent each decimal place? Well, you should have recognized that all the denominators are powers of 10, and again, you've been assessed on this already. So what are the prime factors of 10, 100, or 1,000? Well, you probably could have figured out most of those would be 10 is 2 times 5, and that would be 10 to the first power if we want to bring in some powers, and that would be 2 to the first power and 5 to the first power. Well, 100 is 2 times 2 times 5 times 5, which is 10 to the second power. Notice the pattern there. And the third one for 1,000 is 2 times 2 times 2 times 5 times 5 times 5. Well, 1,000 is 10 to the third power, and notice that we have 2 to the third power and 5 to the third power. So what prime factors make up powers of 10? Well, you will always find factors of 2 and 5. And depending on what the power of 10 is, whether it's 10 to the first, second, third, or fifth, then the powers of 2 and 5 are the same or equal to the factors of, or the powers of 10. So how can the prime factorization of powers of 10 be used to write fractions in decimal form? Well, if you find an equivalent fraction whose denominator is a power of 10, then you can write the decimal representation using place values. So let's take a look at that. So now continuing in your journal, we're going to write down example 3. So what is the meaning of 1/10? Provide a real-world example where tenths are regularly used in the real world. So what does 1/10 mean? And this goes back to what is a fraction. Well, if a unit has been divided or partitioned into 10 equal-sized pieces, or in this case lengths, then 1/10 is the value of one of those 10 lengths or pieces or copies or whatever you want to call it. And for a real-world example, a dime is 1/10 of a dollar, and a penny is 1/10 of a dime. All right, back to your worksheet, looking at example 3. What are decimals? And we just kind of explained that right now in your math journal. Decimals specify points on a number line by repeatedly subdividing intervals into tenths. So again, our whole idea of copies and partitions. If a unit is divided into 10 equal-sized pieces or lengths, then one piece would be 1/10 of that unit. So use the meaning of decimal to relate decimal place value. Well, each place value in a decimal is 1/10 of the value of the place is to its left. So this means that the denominators of fractions that represent each decimal place value must be powers of 10. So 100 is 1/10 of 1,000, and 1 is 1/10 of 10. So it's always 1/10 of the place value to the left. So write the number 3 hundredths, or 3 over 100, as a decimal and describe your process. So we're going to take the decimal form is 0.03, and the fraction includes a power of 10. That would be 100 as its denominator. So the value of the second decimal place is 1/100th. So that means 3 100ths in decimal form is 0.03. All right, let's go back to your journal. So how could we obtain an equivalent fraction to 3/20ths with a power of 10 in the denominator? Well, you know you've got 10 in 20 because the factors of 20 are 2 times 10, but we have some leftovers. So how can we turn 20 into a power of 10? Well, we have to add another factor of 5 to the denominator so that we would have the same number of 2's and 5's resulting in a power of 10. So right now 20 is 2 times 2 times 5. So we need to get another 5 in there, so that's 2 times 2 times 5 times 5. So if we multiply the fraction by 5 over 5, remember if we are partitioning, we are also copying. So that's where the 5 over 5 comes from, because that's equal to 1. We get an equivalent fraction with a power of 10 in its denominator. So let's work this out on your worksheet. So write the number 3/20 as a decimal. Describe your process. Well, the fractional form of 3/20 is also equal to 3 over 2 to the second power times 5. That's where I was getting the 2 times 2 times 5. So the denominator lacks a factor of 5 to be a power of 10. Because again, in order to be a power of 10, we have to have the same number of factors of 2 as of 5. So in order to do that, we're going to multiply the fractional form by 5 over 5 to get 3 over 2 squared times 5. And when we multiply that out, we end up with 3 times 5 and 2 squared times 5 squared. So we get 15 over 100, and 15 over 100 is 0.15 or 0.15. So now do the same thing with 10 over 25. Write that as a decimal and describe your process. So using the example above, how can you rewrite that answer and make it fit 10/25? Well, the fractional form is 2 times 5 over 5 times 5. So what are we missing to get a power of 10? Well, we're missing 2 5s. So 5 times 5 is 1. Well, actually, we can cancel the 5s out. I forgot about that. So we can cancel the 5s and get 2 fifths. But then I need a 2 in the denominator, so I can get a power of 10. So we're going to multiply the fraction by 2 over 2 to get 2 fifths times 2 over 2, which is 4 tenths, and 4 tenths is 0.4. All right, try this again with 8/40. See if you can do it without looking at the answer, and then continue the video to see if you're right. All right, so 8/40 is 2 to the third power over 2 to the third power times 5. Well, you can cancel out the 2 to the third power, all right, and you would get 1/5. The only problem is 1/5 is not a decimal, so you'd have to multiply or at least keep one of the 2's. So they have kept 2, and then you have 2 over 2 fifths. Well, 2 times 5. So now you have 2, and then 2 times 5 is 10, so 2 tenths is 0.2. All right, so now it's your turn to do this on your own. Again, refer to those examples that we just went over. You're going to complete A through D in the same manner. When you are done, continue the video to check your answers. Okay, here is the answers to exercise 2, A through D. All right, so in your journal, let's go ahead and summarize what we just went through. So this is important to kind of come up with an overall theme of what we talked about and just kind of wrap it up with a conclusion. Well, when asked to write a decimal value as a fraction or mixed number, how do we determine the value of the denominator? So think about, how did we determine the value of the denominator when we need a decimal value? The second thing is, if a denominator of a fraction in its simplest form has 4 factors of 2 and 7 factors of 5, describe 2 different ways in which a power of 10 can be obtained in the denominator. So how can, we've only got 2's and 5's, describe 2 different ways where you can get a power of 10 in the denominator. And last but not least, do you think it is possible to write a fraction whose denominator has factors other than 2 and 5 as a decimal. So this is kind of a hypothesis. What do you think? Can we write fractions with denominators that are other than 2 and 5 as a decimal? So here are the answers to those questions. Place value to the rightmost decimal shares the same denominator as an equivalent fraction representing the decimal. If you had 3 factors of 2, could be multiplied in to obtain an equivalent fraction, or 3 factors of 5 could be divided out to obtain a different equivalent fraction. And for the last ponderance, we will wait and see, because that will be our next lesson. All right, see you in class.